Hey everyone, and welcome to another episode of Tech Talks with Tomer. I'm your host, Tomer, VP Product at the Stellar Development Foundation. And on this show, I get to talk to some of the top technical leaders in blockchain about the biggest innovations happening in the space. Today, we have a special treat, two guests. We have Fraser Brown and Riad Wahby. Both are assistant professors at CMU, and both are co-founders at Cubist. So Cubist is a cross-chain dApp development toolbox, and it also happens to be one of our Stellar's Bridge Bounty recipients. So hey, Fraser and Riad, how's it going?
Great.
Not too bad. How you doing?
I'm
Thanks
doing
for
great.
having us.
Thank you for showing up. So let's maybe we can start with a quick intro. Tell us a bit about yourselves and how you ended up in blockchain.
I'm going to let Riad start because he's sort of the reason we ended up in blockchain.
Oh gosh, yeah. I was hoping to go second so I could say, and I incepted them. But yeah. So yeah, for me, I kind of started out like the in the academic world, like working on proofs, like proof systems, zero knowledge proofs, this sort of thing, and it was really actually fortuitous. Kind of, I stumbled into it. It was kind of just this really interesting topic. Started thinking about these things, and this was before there was any application to, or anyone knew about applications to blockchain. And so we would, write these papers and get responses from the reviewers that were like, yeah, sure, but this is just a hammer looking for a nail, right? Like, come on, no one's ever going to use this. And so then suddenly, boom, there was this explosion, and everyone like really loved proofs and wanted to use them for. And I was working with Dan Bonet when I was doing my PhD, and so of course he's sort of involved in everything. And at some point he said, oh, there's this really interesting problem that had to do with signature schemes, and so we started thinking about that. There's this other interesting problem having to do with private airdrops. So I think Dan just sort of like led me along from interesting problem to interesting problem until finally it was just like, okay, this is a great space. There's all kinds of really cool technical problems here. There are interesting things to think about and cool people to work with. And yeah, that was the way I got into it.
And then academically, I work on generally like program correctness, everything from finding bugs in programs all the way to proving that production software actually does what it's supposed to do. And often in the context of compilers, but not always. So I really had no knowledge or interest in the space at all. And then over the course of years, Riad just talked at me about what he was working on. So it was around. But then I think we were talking in the kitchen, sort of about problems of interoperation, actually, in the sort of blockchain universe, and thinking about it as more of a compilation problem. And then I was just totally nerds. I was like, oh my gosh, we need so much infrastructure here. We need the kind of infrastructure I love to work on. Fantastic. And then we also, like, same thing happened with Dayon, our other co-founder, who has a whole other skill set that's also really, really relevant here. So yeah, just sort of happened.
So I do want to dig a bit deeper into this because you're four co-founders, right? And if I read this correctly, two formal verification experts, we got a cryptographer, we got a fintech exec. Somehow you all, you all met, and the thing that came out of it is Cubist. So like, how did that happen?
Well, I think Fraser has given kind of a piece of that story, which is like, researchy kitchen conversation turning into like this realization that, oh, there's actually this really interesting product-ish thing to build. And then, I think roughly the same thing happened with Dan and the two of us. And at that point, I had Fraser helping me to really make the nerd snipe work. And then, well, I mean, look, there's three academics, and we're like, oh, we're going to build a product and like cue the laugh track. It's like, so, okay, well, how are we going to actually do this? We said, okay, well, Anne actually knows how to build a product, like actually knows about how to operate, how to think like really in a paranoid way about, attacks and fraud and this sort of thing, which is, that's the sort of thing that she's been doing for about 10 years is, defending against exactly that in the fintech space. So as we started talking with her, what we realized was, first of all, we didn't know anything about building products. But second, that actually there was this like this way of like thinking in a systematic way about it. It's not just like, oh, this would be cool, but here's a systematic way of figuring out, like, is this the right thing to be working on? Is this what customers need, et cetera? And so, like, I mean, this was like a totally new skill set for three of the four of us, and Anne was sort of teaching us. And so, yeah, I think it was kind of, each of us had this like strength, and like they all kind of came together in a really cool way. So yeah, I don't know. It was fun. I like it.
It actually, that whole process was so interesting because really the three of us, the way we were used to thinking about problems was basically, oh, there's this really interesting research question about approximate typing. How cool. And then you do that because it's cool. So that was our approach. And Anne was just like, oh my gosh, have you gotten any signal that like anyone wants this? And we're like, well, it's really cool. Of course they want it, right? Like people want cool stuff. No, not true. So then she was like, maybe you should talk to some people about what to build. And so then we did that. And that's, yeah, I mean, frankly, it would be really cool to talk to more people before starting a research paper. I think that would be one potentially useful approach.
Alternatively, the bar for a successful company could just be novelty, and then we would be really well set, because it's just like writing a paper at that point.
That would be amazing. So maybe you can give us just a high level quick overview on like what Cubist actually is.
Oh, do I get to do that? Okay. Let's see. So we think of ourselves as just like sort of building developer tools for like secure and productive development in Web3. So that's a super high level thing. So what does that really mean? So the kind of the first product, the first thing that we really thought hard about was a software development kit that lets you think about your distributed application as if it runs on a single chain, even if it runs across many different chains, including off-chain code, et cetera. So, I think if you look at the way that folks build like multi-chain apps today, there's a lot of mixing of layers of abstraction. So, let's say if I'm running on, I'm going to work with Sorbonne, and I'm going to work with Ethereum, and I'm going to work with, Avalanche, whatever. I'm going to work with like 3 or 4 different chains. And I start by writing my application on each chain, and then like thinking at a really low level about like how the bits and bytes flow from like chain A to chain B to chain C. And then maybe I, jump in and use some provider who like actually gives me the bridging connections between the chains. But as soon as I do that, like the actual way, like mechanically, what I do when I like pull in, bridge provider X is I go and I get their code, which is like, if I'm on Ethereum, it's like a Solidity based contract. And I inherit from that code. And so that means that I basically just have pulled their code base into my code base, right? So at the end, what I have now is an application where all of my logic is totally mixed with all of the logic of the bridging implementation. And so now I'm kind of stuck, right? Because if I want to say switch bridge providers, or if I need a different bridge provider because I need a different connection that my first provider didn't give me, then well, I get to rewrite a bunch of code, or I get to throw things away or whatever, right? So that's kind of a weird thing, right? It's if we're talking Web 2, like if I build a web app, like I don't start by implementing TCP and then like go from there, right? Or maybe some people do. I love TCP, but that like people would look at you like you were crazy, and yet that's basically the status quo. So we said, okay, look, there are techniques for handling this sort of thing. There's like, and this is where I should shut up and let Fraser talk, because she's the one that actually like really designed this piece of the system. But basically the idea is, look, you describe where your code runs, and the SDK figures out how to connect those things together. And it's like there are patterns of the way that these things interconnect. And like your code gives enough information for us or for the SDK to generate those connections, without your having to do it. So that means that what you end up with is an application where, if you really kind of think about it as all running on one chain, it's just like, here's the logic and here are the pieces and here's how they talk to one another. And then, oh, by the way, in my configuration file, I can say this one runs on chain A, this one runs on chain B, this one runs on chain C, and here's my bridging provider between them. And like all of that low level weirdness that doesn't have anything to do with your application's logic, all of that gets generated automatically.
And the nice thing about code generation in this situation is it's actually a lot easier to get right and to prove right. So if you're coming at this from a sort of verification perspective where you're like, okay, I want to prove that my application does the right thing. If you're looking at a bunch of different applications that all use existing bridge provider code and then intermix that with our application logic, like actually proving those applications correct is going to be really, really hard, right? You're gonna, like, every single thing will look different. That's never good for the people. But if you're actually just generating code, that's one pattern, that's one pipeline. Like, there's so much less that you actually have to prove correct if you're trying to get an end-to-end guarantee. So that's one reason I really like this code gen approach. Aside from all the things, that it makes easier for the user, it also actually makes things more correct.
So I am curious, Fraser, from your perspective, you spend most of your professional life in non-blockchain land. And coming from that background, how is the experience of onboarding into the world of blockchain in terms of, from your angle of, the type of tools that are available for software developers?
That's such a fun question. Okay, so there are two parts, I would say. One bad, one good. The thing that is cool is, at least in like the smart contract area, people use a lot more heavyweight of correctness tools than they tend to in normal software development. Just because the code is so critical and it's quite small typically. So you're actually looking at a case where verification is both tractable and reasonable to do, right? Like, on the other hand, if I'm just some dude writing some random web app, like a calculator, okay, probably it doesn't need to be verified. If I'm writing a smart contract, okay, now I'm very motivated to actually verify that code. So one thing I think is really cool is all the both academic and industrial options for heavier weight techniques like formal verification, like symbolic execution. That's really cool to see. I've actually used some of these tools. We had to write a smart contract for one of our other products, and I used Sartora's prover to verify it. It was so fun. So yeah, yay. I mean, you really wouldn't find that in any other area. On the bad side, so typically programming languages, okay, they don't have the best presentation of their own semantics often, but man, trying to figure out certain solidity semantics is really tough. People seem like the day-to-day development experience in everything from what are the semantics of the language to what tools am I going to use to what's my CI/CD pipeline, all of that stuff seems really less good than their Web 2 alternatives. So on the one hand, we have amazing verification tools, and on the other hand, it's way harder to just test your stuff or figure out what the language is telling you it does. So I find that paradox very interesting.
Well, to be honest, I'm surprised that there was a good part to that answer. So that was already better than I expected. Yeah, tooling and blockchain. There's. I mean,
it's bleak. It's bleak, right?
But you're also in this position where you have visibility into the guts of several blockchain platforms because you support more than one blockchain, and you're really in the guts of these smart contract runtimes. So how is the variance between the different platforms? Obviously Soroban is the gold standard, but tell me a bit about about the rest of the space.
Actually, Riad, you start. I want to think a little more about.
Yeah, and it's okay to talk shit. We don't. Our view audience is very small. Yeah.
This one's going to blow up. I have a feeling we're gonna say just the right words. No, okay. So my perspective is obviously a bit different than Fraser's, but just the way that frequently I've looked at these different. The guts of these different VMs is from the perspective of how are we interacting with them? What am I as the if I'm a remote node and I'm making queries, this sort of thing. And so just a slightly different thing. There, the variation is just incredible, right? So on the one hand, you have smart contract platforms where there's like super weird semantics of like how you I'm trying to think of a polite example here. So there's a well-known blockchain where there's sort of this weird idea that you're like kind of pulling in pieces of system code, but until recently, those pieces of system code were not actually, validated as like the system code. So like you can think about this as basically like, yeah, your operating system, except any user space process can just like write over the code in the operating system. So like, wow, okay. So there was like a little bit of a missed connection there, right? So I think there has been a little bit of this kind of thing where it's like, well, each of these VMs is kind of an operating system, or roughly a processor and a really low level guts of an operating system. And some of them have been really carefully thought out. Here I'm thinking of Soroban. And some of them have sort of grown like kudzu or ivy, and sometimes that ivy grows over and hides a really nasty rock. Yeah, I mean, to me, it's like when you interact with these machines, you kind of see like the ethos of the developer, and sometimes that ethos is like, well, we're going to be very careful about how each piece talks to each other piece, and sometimes, unfortunately, that ethos is more like, well, okay, next we need this thing. Let's do it this way. Okay, next we need this other thing. Let's do it this way. And so, you can end up with a little bit of a grab bag, and sometimes the grab bag is full of knives.
I like that answer. Mine is much maybe simpler and sadder. I just want semantics. I want front-end language semantics. I want IR semantics. Like, please just tell me what it does. That's all I want. Or tell me rather what it should do.
That speaks to another thing that would be nice.
That's the bar. Sorry. No, that was all.
Yeah, I was gonna say that speaks to another thing that would be nice, which is documentation. So like, if anyone is listening, like, please, like, there are probably dozens of really good technical content writers who are stuck in like jobs that they don't like, who would be awesome at writing your documentation. Like, go find these people, make them heroes, like make your documentation better. Like, you'll make the world a better place.
Awesome. And I'm really glad to hear you. Well, not glad, it's a bit sad, but the reason why we ended up in Stellar going with Soroban, which is like, a bit of a new platform, is because we couldn't really find something that makes perfect sense. And so we decided to build it ourselves. And we hope you enjoy building on that.
You decided to build it yourselves and then tell people what it does. Thank you for that.
You're welcome. I'll send that to the team. So I do want to talk a bit about Riad. You were talking a bit about zero knowledge proofs. Obviously, I understand you know a thing or two about them. So from my perspective, it looks like, and you said it yourself, like until a few years ago, zero knowledge proofs were this like theoretical niche of computer science. Not what I would define as like cool technology for the non-Riads of like the world. And then the world of blockchain started adopting ZK initially for privacy. And then things really exploded when people started talking about zero knowledge as like scalability solutions, and specifically ZK rollups. So how did we get here? And what does this look like? What does this look like from an expert's point of view?
The how we got here question is a really good one. I think the answer is basically, there's a little bit of, well, okay, depending on which blockchain you think of here, but like, I think a lot of the drive for ZK based L2s has been Ethereum, and EF really likes them, and with good reason. I mean, there's like sort of technical cool stuff there. But I think at the end of the day, there's like also the big problem that EF has been trying to figure out for a long time is like, how do we actually get performance that's pretty reasonable? And like ETH2 has definitely improved things in certain aspects, and but at the end of the day, like, this is like the fundamental problem that everyone who's in the Ethereum ecosystem is worried about, is like, how are we going to be able to handle a reasonable number of transactions? And Yeah, I mean, look, obviously there are solutions. The dank strategy is coming, and this sort of thing, right? So like, things are getting better. Um, but I think this has the makings, like just as a total outsider, really, this has the makings of one of these eternal problems. Like we're always going to be trying to make things better. We're always going to be trying to make things faster. We're always going to be trying to, get more throughput, and that's good. That means that the system is like successful. And so I think partly that motivation has driven this a little bit of maybe a hope cycle for rollups. And I say that like with love. Obviously, I think that you know proof technology is awesome. But I think if you look at the reality of it today, like the numbers aren't there. Like the performance of rollups is not really even close to on par with like reasonably performing blockchains. I mean, like if we're comparing to Ethereum, then like, yeah, but you're setting the bar too low if you're comparing to Ethereum. So in terms of performance, I mean, obviously in terms of security, whatever, like Ethereum is fantastic, but Ethereum's performance is, I mean, I think we can all be honest with ourselves, it's not very good. And so, there's this question like, okay, are we really getting there by adding super heavyweight cryptography to the equation? Asymptotically, the answer is yes. Like if you're a theoretical computer scientist, you say, well, sure, look, the verifier's work is only logarithmic in the amount of work that the prover that actually gets done. And so like, sure, that's an exponential improvement. Okay, great. Except like who's generating the proof? How long does it take to generate the proof? How many transactions or whatever can you fit inside the proof? And when you actually like put pencil to paper and look at numbers today, those numbers are not yet good. So things are getting better. I think there was sort of this period 2018, I think of it as like 2018 to 2020, 2021, where the slope was actually very, very sharply positive. I think we've leveled off a little bit. I don't think the rate of improvement has been as high recently. But I think this is one of these things where it's a punctuated equilibrium. Like we're going to see jumps in performance. So the core challenge here really is that in order to generate a proof, the prover, the one's actually like doing the hard work, the prover is doing strictly more work than you would do to just like check the program or check the transactions, right? And so then the question is like, what's the ratio there? The ratio is like 1 million today or something like that. Maybe it's 10,000, maybe it's 100,000. Depends on exactly what the proof system is. And so there's this like 1,000,000x or 100,000x blow up from like just checking a transaction to proving that you did a transaction correctly. And that can make sense, right? If you have 1 million people checking the proof and the proof is much easier to check than generating the proof, then yeah, it makes sense for one person to do hard work and everyone else to do easy work. So from that perspective, things are fine. The part that's the problem is like, okay, but how, like, where are you finding the machine to generate the proof? And it's, you've got this massive slowdown. There's also memory consumption issues. Like this is like the scaling limit for most proof systems isn't like how much time it would take to generate the proof. It's how much memory do you have on your machine, because you have to sort of work over a representation of the entire program at once, right? It's like, I mean, as an analogy, I promise I'm going to shut up in a second here, but as an analogy, imagine that like, well, I'm going to run Excel for 10 minutes and it will only allocate memory over that whole time. And like every action that I take requires more memory. It's like every proof system is just a space leak, like baked into like a cryptographic souffle. I mean, so like this is the problem that we're kind of fighting here, is that like, yeah, the prover is doing hard work and is doing like a lot of intensive memory kind of work, and on top of all the sort of cryptographic operations, et cetera. So how do we get better? Well, so people are working on things like distributed proving, things like, sort of recursive proving, where, somebody generates a proof, a bunch of people generate proofs, and then somebody generates a proof of those proofs, and then somebody, and then maybe you can post that to the blockchain. And that makes things better because maybe you can break the problem apart a little bit, or, each proof can, reach this much, can do this much work, but now we sort of multiply that by the number of proofs that we can fit into the next level of proof. So all of these strategies are making the scalability better. Yeah, it's a matter of now balancing between scalability and latency and practicality of spending 1 million x the cost of generating of checking a transaction. I think there will be applications where that makes sense. I think that there are applications today that are aspirational, where so far it's really about the hope that in the future it will make sense, and much less about whether it makes sense today.
I think proof's done. Proof's done. Good. Okay. It's a dangerous question. It's just a dangerous question.
Yeah. This I've been like thinking about it, and like really just like my heart has been hurting about like the state of like practicality and proof systems for like multiple years. That was like the topic of my dissertation was basically, are proofs practical and why is the answer no? So ish.
So you're just trying to prove your thesis, basically. Yeah, I'm really glad you're saying this. It does feel like there's a bit of a reality distortion field right now around the world of zero knowledge proofs. And I saw, and I obviously I don't want to put you on the hit list of any like ZK company or anything, but it does seem like there was this project that tweeted a few weeks ago about building a ZK sequencer, a ZK rollup sequencer that does 76 transactions per second, and they were so proud. And I was like, 76, that's it's nice that things are improving, but these are not actually like numbers for scalability. So seems like there's still the distance to go there.
Yeah, and I'm glad that people are doing it. I mean, look, as an academic, like, and this is about to like, this is a very, very pragmatic, but possibly also slightly ugly thing to say. Like, as an academic, I'm really glad that people are just dumping money into this area, because like, frankly, it's my area of research. Like, great, there's like grant money floating around and stuff like that. So like academics love this, and this, I mean, that's not a bad thing, right? By the way, like I say that as a joke, but like this is good. There's interest in this. It's a cool technology. People are willing to pay for it. That's fantastic. But I think people should be, should be reasonable and should admit to themselves that like we're still in the research project phase here, which that's fine. That's good. Research projects frequently turn into things like going to the moon, but sometimes it takes a while.
Let's stop talking about ZK for a bit. Go back to security, which is something that we talked about earlier. So Cubist, a lot of the value prop here is security for multi-chain dApps. Now, the way that I see this, there's a lot of rope for developers to hang themselves with in regular, one chain land. And it sounds like adding multi-chain to the mix creates, n squared rope. So like, how do you mitigate this, and how do users of Cubist should think about security?
Yeah, I think a lot of so there are a few questions here, right? There's the question of the correctness of the application itself. And then there's the question, okay, how do you make it easier for people to actually test their applications and make sure they implemented the logic they meant to implement? So we sort of are interested in both those avenues. One sec, sorry. So on the one hand, I talked a little bit about the correctness of code generation. We're really trying to separate application logic from sort of infrastructure logic, so that then we have a way of making sure that infrastructure logic is correct by construction, and maybe even one day proving that it is correct. So that takes care of the infrastructure piece. I won't get into that too much, but then we still have the application logic piece. And what are people doing today? Well, they don't tend to have like very comprehensive, say, CI/CD pipelines, right? Testing is not maybe the strongest suit of every company on the market right now. So that's another thing we're trying to make a lot easier, so that people are actually motivated to test their programs once they've written them. They're really interesting questions. They're both related to like standard software engineering, like Web 2 stuff, but also more Web 3-ish problems, right? Because the minute you're trying to manage things like testing and deployment and upgrades and all of that like operational stuff, now you have a bunch of keys floating around. That's hard. So you have more infrastructural questions that are distinct from questions about your code. So we're both trying to make it easier to like test your code by spinning up a bunch of local dev nets, for example, but also making it easier to actually manage the operational piece of testing, deployment, upgrades, et cetera.
Yeah, I think when we started looking at the space, the lack of tooling for testing was pretty insane for us. The fact that you could go through a tutorial that teaches you how to build smart contracts with not a single bit of information about how to actually test the thing. That's pretty wild. And to think that until not so long ago, like, you know, you had to like run your own node, and there's like this indirect testing, like no way to unit test. And I do think like there's definitely a lot of progress that has been made in the past kind of like year or two. And I think specifically in EVM land, Foundry is like this really great toolbox, and we've taken a lot of inspiration from Foundry, although instead of like building bespoke tooling, what we're trying to do with Soroban is to really kind of like bank in on like the WASM and Rust ecosystems and the tooling that's available there, rather than kind of like try to reinvent the wheel.
Yeah, I'm actually curious how you sort of came to your testing design, because that was something when we were first playing around with Soroban and writing smart contracts for Stellar, that was something that was really sort of fun and impressive, how easy it was to just like, okay, you can test the contract. So yeah, I'm curious how you settled on that design.
Well, to be honest, we actually did we did a bunch of conversations with folks from the industry to figure out the like requirements from a new smart contracts platform. One of the people we talked to was Jorgis, the CTO of Paradigm, and he pointed us at Foundry and this idea that it like everything should start from tests, basically. So what we wanted to do is build something that gives you like a really fast kind of like test cycle, and gives you like different basically like this different levels of testing. So you can start off like really simple unit tests, and then you could go to like local testing of like a sandbox, and then like an actual network, and then like a test net. Rather than an EVM land, it's been like for years it's been only kind of like on the network level, and we really wanted something that's like really ideal for local testing and like rapid iteration. So that's how it became to be. We have some very unique, great talent in like the Rust ecosystem that's in Stellar. So I think this idea of building the Soroban env in a way that's completely composable, and that you can either ship it in Stellar Core or some other blockchain, but you can also just link to it directly from you can compile your contract linked directly to the env, and then you can use the entire breadth of developer tooling that you already have, which is really awesome.
Yeah, that's so cool.
I totally agree. And sorry, go on, Fraser, please.
I actually have to run now, unfortunately. So I'll let you spend another hour talking to Riad about zero knowledge proofs. I'm sure you guys will have a great time. But thank you so much for having me. I'm so sorry to have to run.
No worries. Thank you, Fraser.
Thank you. Bye.
So one thing that you said that that really touched a nerve for me in a good way. I think touched a nerve was the wrong choice of phrase there. This idea that test nets are testing is like, as you said, that's crazy. Like it should have been called staging net or something, right? Like that's the right term for it, right? It's like the test net is like the last thing before you're ready to go to prod. It's not like, yeah. So this like changing the attitude, I think is a really important thing. And I think that like this is like the fact that Stellar is taking this approach with Soroban, to me is like, that's fantastic. Like really just being able to sort of evolve your application from unit tests to local tests to, and I think one thing that I hope that we'll start to see is, testing, testnet-ish environments that are, long lived, but sort of organization level. And I think making that kind of thing really, really easy is super cool, right? Like, if my engineering team like has a test net that we've been running for the last 2-3 weeks, and maybe every once in a while we tear it down, but like it's really intended to be like it's running for a long time, and it's a network like any other, but it's only us. Like, cool. That's the kind of thing that like if that's easy, that'll make life a lot better for people. So
yeah. Anyway. Completely agreed. So we're almost at time. One thing that I did want to touch on is, it's crypto winter right now. and you still managed to raise a round of $7 million, I think. So congrats, that's awesome. What does it mean for you folks to build during a crypto winter?
Well, so first of all, don't look now, but like the prices are kind of creeping up again. Like I don't know, do we call Bitcoin the benchmark? But like Bitcoin's at 30K or something. So like, yeah, I guess we're in a crypto winter, but like, man, it's a warm winter, at least at the moment. But look, so that's not a serious answer though. To me, like the macro environment now doesn't matter all that much to us because we're in the process of building a bunch of things, right? And I think a lot of folks have this opinion, right? Right now we're building. Whether there's a bunch of churn around us or not is like, yeah, it's unfortunate if a bunch of projects are going away. But on the other hand, a bunch more projects are going to be coming out in the next year or two, I'm sure. And those are the people that we're really building for, right? You're always chasing something that's a year or 6 months out or so. So I think the other thing is like a shakeup in the industry is good from the perspective that I think there is a lot of talent that's been sort of focused on maybe less than perfect projects, like significantly less than perfect, and I think a little bit of stripping away of some of that distraction is good. So I think it's healthy for the space overall, and yeah, from our perspective, like great time to be building, keeping our heads down, just cranking away at some code.
That's awesome, and I completely agree. I think this is probably my third or fourth winter now, and it's cliche, but it really is great for building, and it's great for like reducing the noise and kind of like getting rid of some of the bullshit that's out there. So I think it's great for the industry.
Yeah, I'm with you. I think. Yeah, we'll see what happens. There's all kinds of uncertainty, as everyone knows. You don't need me to tell you this, but there's also like fantastic technology. There are real solutions to real problems. Those will, in the end, emerge. Like that's what will win. It's not going to be, some, weird idea about how to, get 6 of your friends to get 6 of their friends to whatever, right? Like that's all a distraction. The good stuff is here's a real problem. Here's something that the existing financial system is not addressing. And this technology actually makes it possible. So to me, like building for that, building with the idea that once we have infrastructure, once we have security, once we have like really systematic ways of thinking about like building good software in this space, then like there are really, really important applications, and absolutely those will win.
I think this was a really great summary of our conversations and very inspirational. Thank you, Riad, for that. So where can the audience follow Cubist, you, Fraser, and learn more?
Yeah, so on Twitter we're Cubist Dev, no dash or dot. We're also cubist.dev, our website. And between the two, I think they can find us. We have we have a Telegram channel, and we have a few other ways to contact us. So yeah, hit us on Twitter or talk to us on Discord, whatever it is. We're always happy to chat, and yeah.
Awesome. Thank you so much for coming. It was great having you and Fraser here, and have a great rest of your day.
Thanks for having us. I really appreciate it. Sorry that Fraser had to run away. She had another engagement, but yeah, this has been fantastic. As always, a pleasure to talk with you, Tomer.